Okay, the last video in section 12.1 talks about a couple other ways of displaying data. A couple that you've probably seen before are what we call bar graphs or histograms and line graphs, which they call frequency polygons. And so a bar graph can take that same data and display it using kind of bars and kind of show different frequencies. So instead of the frequency distribution chart that we did in the last video, this takes that same data, the number of boys they said grew the most, and displays it as a bar graph, a histogram. And so you can see that most boys said they grew the most at age 14. This were the ages that they grew the least. Remember, that was the 10, 17, and 18. So it's the same data, just displayed in a different manner. So a histogram or a bar graph instead of a frequency distribution chart. The other one was more of a line graph or a frequency polygon, doing the same kind of idea, kind of taking the data and displaying it with dots and then connecting those dots with a line. You can see again that it peaks at age 14, that it's lowest at age 10, 17, and 18. So you should be able to take these bar graphs and these line graphs and be able to answer questions if I give you the data displayed in each of those forms. Okay? All right, the last thing that we're going to talk about, way of displaying data, is what we call stem and leaf plots. You might have seen these back in school a long time ago. It's not as frequently of a display that we use, but it's called a stem and leaf plot. It is a way of displaying data by separating the tens digit and the units digit. We call the tens digit the stem, so in this case it would be the 8 would be our stem, and then we call our units digit, our ones digit, the leaf, so in this case the 6 would be our leaf. And we would go through and we would display and separate all of our 80s, all of our 70s, all of our 60s, and so on. Let me show you an example. So in example 5, we have these data items. It looks like this was the same as the test scores from the previous example, but instead of displaying it as a frequency distribution chart, we're going to do it as a stem and leaf plot. So we're going to go through and we're going to figure out what data items we have. So looking at our data, it looks like we have some numbers. The lowest numbers that we have are in the 40s. We also have numbers in the 50s. We also have numbers in the 60s, 70s, 80s, and 90s. So I'm going to put the stems there. You can do it in a different order. You can do 9, 8, 7, 6, 5, 4 the other way. That's fine too. And then we're going to go through and we're going to list how many of the data items were 40s. So 41, 42, how many of them happen like that? So when I go through and I look, I notice that the first 40 was a 47. So that's what I'm going to put here. I'm going to put the 4 as my stem and the 7 as my leaf. I'm going to go through my data again and I'm going to find the next 40. And so I notice that there was a 45 and a 43. So I'm going to list those, 45, 43. I'm going to separate my data items with commas so I know that it's something different, not 475 or something like that. So this number represents 47, this number is 45, this number is 43. And again there, it doesn't matter the order that you put it in. It might be a little bit easier to kind of interpret if it was in order, but it does not matter as long as you've listed all of the data items that are in the 40s. So you should have 3 of them. Do the same thing with all of the 50s. Go through and list all of your 50s. If you've noticed, I underlined them in purple, and then I'm going to go ahead and list them over here in my stem. I had a 57, a 54, a 56, a 57, a 50, and a 59. I didn't miss anything, did I? Okay, so you should have the same stem and leaves as I do, representing all of the 50s. Pause the video, do the same thing for the 60s, 70s, 80s, and 90s, and then come back and see if we have the same numbers and we didn't miss anything. All right, after filling out your stem and your leaf, your stem and leaf plot should look something like mine. On your exam, I want you to be able to fill out and make a stem and leaf plot, but I also want you to be able to interpret a stem and a leaf plot if I gave you one that was already completed. For example, what if I asked you about this number right here and what it represented? Well, because that number had the stem of 7 and a leaf of 9, that would mean that one person got a 79% if this were a test score. Or what if I said, how many students earned an 80% on this test? Well, I would look for the stem that was an 8 and the leaves that were zeros, and I can say that 2 of my students got an 80. So I need to make sure that I list every single data item in there. So I want to make sure even if it repeats, I continue to write all of those out so that I know how many students got an 80, how many students got an 81, and so on. So make sure that you know how to make a stem and leaf plot and you know how to interpret a stem and leaf plot. Okay? All right, the last little thing we're going to talk about is deceptions in displays of data. So you have to be really careful sometimes when you are given displays of data because sometimes they can be deceiving. And so if you look at the chart in the middle, this chart is talking about the different years from 2001 to 2005 and the poverty rate, right? People that are poor. And if you look, it started off at 11.3 and it very slowly went up and it got up to 12.7. Now, yes, it is increasing, but if you look at those numbers, it is not increasing drastically. However, if I displayed the data like I did on the left side, doesn't that line graph look like it's increasing really quickly and that increase is large? Versus if I displayed the data like the right side, the increase, you can see it still, it's going up, but it looks like it's going up very slowly. So depending on who was displaying the data and what they would want you to get out of the data, they might represent it like the left side versus representing it like the right side, or vice versa. Maybe I wanted to show you that the poverty rate wasn't growing very high. I would use the right side instead of the left side. You just have to be careful in what you're looking at so that you're not deceived by the data. Because if I was displaying the data like the left side, I might say, whoa, look at the poverty rate. It is growing so drastically. I'm so worried. When really, you've got to be careful to look carefully at the numbers to see if it's really growing as high as it looks. You notice that the scale on each of these is a little bit different. That's why it looks like it's growing so drastically on the left versus the right side. So just be careful that when you're looking at data, you're looking very carefully at how they're displaying it so it doesn't look larger or smaller than it actually is. Okay?